Hello student, my name is Rahul Soni. I would like to give my short introduction. I have worked in all national level institutes of India like Catalyzer, Momentum, Akas and Allen in major cities of India like Kota, Bangalore, Indore, Bhopal and Jabalpur. I will cover and 100% HC Verma in my videos and Allen modules, good questions of Allen module and Akas module, and I will include all previous year questions of IIT and NEET as well. I will cover good questions of FITZE module also. I will be teaching from very zero to the topmost level. Stay tuned. In my very first lecture, students, I will teach you electrostatics of class 12th. In electrostatics, I will teach you charge. In charge, I will explain you what is charge, properties of charge, methods of charging of a body, Goldie flectroscope, and different questions of charge. After completing charge, I will teach you Coulomb's law. In Coulomb's law, I will teach you basic what is actually Coulomb's law, and then I will teach you vector form of Coulomb's law, and then we will solve questions based on Coulomb's law at different levels. After completing Coulomb's law, we will start electric field. In electric field, first of all, I will teach you electric field due to point charge. Then I will teach you electric field due to ring, then electric field due to rod, and then electric field due to sphere, solid sphere, hollow sphere, uniformly charged sphere, non-uniformly charged sphere. After completing that, I will teach you electric field due to an electric dipole. After this topic, I will teach you Gauss law, basic definition of Gauss law, and application of Gauss law and questions based on Gauss law. After completing Gauss law, we will start potential. After completing potential, I will explain you electrostatic potential energy. Let's start with charge. To understand electrostatics, we need to understand charge properly. Now, let's start with charge. What is charge? Read this carefully. It's a property of matter. Well, now, what is matter? Matter is this is matter, this is matter, whatever we can touch or whatever quantity which have mass is known as matter. Mass is also a property of matter. In the same way, charge is also a property of matter. Like we all have some property. Like I have property of, suppose I am a good artist, I can draw very good drawings. So I have a property of drawing. In the same way, charge is a property of matter. Remember this line, smallest definition of charge. We represent charge by capital Q or small q. Its unit is Coulomb. Charge is of mainly two types, positive charge and negative charge. Charge is a scalar physical quantity. Now we need to remember this important point, electron. Electron is the smallest free to move charged particle. We represent charge in one electron by E, and its value is minus 1.6 into 10 to the power minus 19 Coulomb. We cannot divide electron further. Remember this, we covered this thing in class 10th. Positive charge will repel each other, negative charge will also repel each other. So we can say similar charges repel each other, but opposite charges attract each other. You can see positive and negative charge, they are attracting each other, and positive and negative they are repelling each other. And the force between two charges is known as electrostatic force, and this force is a non-contact force like force of gravity. I told you students what is definition of charge. Now on the basis of definition of charge, we can solve these true or false questions. My first question is, if matter is present, charge must be present, true or false? This is false, because the statement is very rigid, charge must be present. I told you charge is a property of matter, but it does not mean that whenever matter is present, charge will be there. No, because generally all the atoms are neutral. For example, suppose any atom have 5 protons and 5 neutrons, then this atom may have 5 electrons also. Now electron and proton have same charge. Proton have positive charge and electron have negative charge. Now look at this diagram carefully. how many electrons you can count? 5 electrons. And how many protons? 5 protons. An electron and proton have same charge, but electron have negative charge and proton have positive charge. So what is net charge in an atom? Net charge is 0. That's why if matter is present, charge must be present. Wrong, because here matter is present, electron is a particle, this is matter. This atom is example of matter, but net charge is 0. That's why this statement is wrong. Now read second statement. If matter is present, charge may be present. Yes, correct. If matter is there, charge may be present, may be absent. Now let me remove one electron. Now think in this example. How many protons you have? You have 5 protons and 4 electrons. Now because positive charge is more than negative charge. Positive charge is more than negative charge. So net charge is positive. See this? What I did, I just removed one electron. So now if matter is present, yes, charge may be present and may be absent. This statement is not rigid. That's why this is true. Remember, if we have matter, we may have charge, we may do not have charge. Okay, now read third statement. Without matter, charge is not possible. Correct. If we have matter, then only we may have charge. Now next statement, matter is absent but charge is present. Impossible, because charge is a property of matter. Without matter, we cannot. Atoms are generally neutral. Why? Because number of electrons and number of proton in an atom is same. That's why net charge is 0. For example, if I touch this board, I'm not getting shocked. I'm touching anything. I'm not feeling any kind of shock, because net charge is 0. Because number of proton is equal to number of electron, and electron and proton have same charge but opposite in nature. That's why generally all the atoms are neutral and their net charge is 0. The second point is, if we have matter, we may have charge and we may not have charge. And the third point, without matter, charge is not possible. And the last point, the smallest free to move charge is electron. Let's speak with me. Charge is a property of matter. Now let's understand properties of charge. The first property of charge is quantization of charge. Now the meaning of quantization, we can understand quantization of charge from the point we already discussed, that we cannot divide electron further. The smallest free to move charge is electron. Now any amount of charge will be made up of electrons. For example, let's now assume the currency is only 1 rupees coin. Suppose I have 10 rupees, then how many coins I may have? Simple, 10. Suppose you have 15 rupees, then how many coins you have? 15. Right? In the same way, the only currency of charge is electron. Any amount of charge will be made up of electron. That's why if you have 1 electron, you have E charge. If you have 2 electrons, you have 2E charge. If you have 3 electrons, you have 3E charge. But if you have n electrons, you have an E charge, right? Because we cannot divide electron further, that's why n must be integer. I have clearly written in the definition, any amount of charge is equal to integral multiple of electron. You can have 1 electron, 2 electrons, 3 electrons and n electrons, but you cannot have half electron. That's why we can write any amount of charge Q is equal to NE. Now n can be, where n is 1, 2, 3, only integer. Now let's try to solve this problem on the basis of quantization of charge. Find number of electrons we need to remove to get plus 1.6 coulomb charge. It's so easy. For you, quantization of charge is Q is equal to NE, where n is integer. Now let's write formula. Q is equal to NE. Now what is value of Q? 1.6. N is unknown, and what is E? E is 1.6 into 10 to the power 9 minus 19. 1.6 and 1.6 will get cancelled, and you will get N is equal to 10 to the power 19. It means you will have to remove 10 to the power 19 electrons to get plus 1.6 coulomb charge. Now let's try to understand next property of charge, that is conservation of charge. We cannot create charge and we cannot destroy net charge. Sorry, we must say net charge. Never say charge. I always speak net charge. net charge of universe, net charge of world is constant. We cannot change net charge because we cannot create net charge and we cannot destroy net charge. Let's try to understand conservation of charge with the help of one example. The name of example is pair production. Now imagine we are passing gamma ray through very high electric and magnetic field. By passing gamma rays through very high electric and magnetic field, we get electron and positron. Now what is positron? Positron is antiparticle of electron. Mass of positron is same as electron, but charge is positive. Electron and positron have same charge. That's why net charge right hand side is 0 and left hand side also net charge is 0. So net charge both the side is 0. That's why we can say this example support conservation of charge. Gamma ray is very highly energetic ray which have net charge 0. Let's try to understand another example of conservation of charge. The name of next example is pair annihilation. Now imagine a positron and an electron. Somehow if we make a positron and electron collide, we will get gamma ray. Now what is gamma ray? Gamma ray is very highly energetic ray which have net charge 0. Now both the side again net charge is 0. Here also both the side net charge is 0. Here also both the side net charge is 0. So both examples explains how charge is conserved. Although we have created two charged particles, we created positron and electron, but net charge is 0. So we can create charged particles, but we cannot create net charge. Listen again, we can create charged particles, we can destroy charged particles, but we cannot create net charge. Take a look again, net charge 0, net charge 0. So we created charged particle, but net charge is 0. This represent very high electric field and this represent very high magnetic field. एक बार फिर से समझते हैं क्वांटाइजेशन ऑफ चार्ज क्या है। इमेजिन कि कल दिवाली है और आप किसी बड़ी मिठाई की दुकान पे जाके सारी मिठाइयाँ टेस्ट करते हो और फिर बोलते हो कि भैया 2 पीस बर्फी पैक कर दो, देगा क्या? नहीं देगा ना। वो आपसे बोलेगा भैया 1-1 किलो के पैकेट है, या तो 1 किलो मिलेगी, या तो 2 किलो मिलेगी, या तो 3 किलो मिलेगी, 1 किलो से कम नहीं मिलेगी। तो आपको बस ये बात समझ में आएगी 1 किलो से कम नहीं मिलेगी, तो आप बोलोगे भैया 1.5 किलो दे दो। भैया मिठाई वाला फिर बोलेगा भाई बड़े भाई 1 किलो के मल्टीपल में मिठाई या तो 1 किलो मिलेगी या तो 2 किलो मिलेगी। इन द सेम वे एनी अमाउंट ऑफ चार्ज इज इंटीग्रल मल्टीपल ऑफ इलेक्ट्रॉन। या तो एक चार्ज या तो ई चार्ज हो सकता है, या तो 2e चार्ज हो सकता है, या तो 3e चार्ज हो सकता है, या तो ne चार्ज हो सकता है। इसलिए क्वांटाइजेशन ऑफ चार्ज मतलब Q इज इक्वल टू ne। एक क्वेश्चन देखते हैं। इस क्वेश्चन में 1.6 कूलम चार्ज अगर चाहिए है तो किसी भी मटेरियल से कितने इलेक्ट्रॉन निकालने पड़ेंगे। देखो मैंने पहले भी आपको जनरली बताया है कि नेट चार्ज 0 रहता है क्योंकि नंबर ऑफ इलेक्ट्रॉन इज इक्वल टू नंबर ऑफ प्रोटॉन। अगर हम किसी मटेरियल में से इलेक्ट्रॉन निकालें तो उसमें पॉजिटिव चार्ज ज़्यादा हो जाएगा, तो किसी भी मटेरियल को पॉजिटिव चार्ज देने के लिए उसमें से इलेक्ट्रॉन निकालने पड़ते हैं। अब क्वेश्चन क्या बोल रहा है कि किसी मटेरियल को अगर प्लस 1.6 कूलम चार्ज देना है तो कितने इलेक्ट्रॉन निकालने होंगे। हमने कुछ नहीं किया, सिर्फ Q इज इक्वल टू ne लगाया। Q की जगह 1.6 रखा, n अननोन था तो उसको n रहने दिया और e की वैल्यू रख दी, सॉल्व कर दिया, n इज इक्वल टू 10⁻19 आ गया। मतलब 10⁻19 इलेक्ट्रॉन निकालो तब इतना चार्ज आ जाएगा। चलो क्वांटाइजेशन ऑफ चार्ज एक बार फिर से समझते हैं। पूरे यूनिवर्स का चार्ज, पूरे यूनिवर्स का नेट चार्ज फिक्स्ड है। मुझे नहीं पता वो क्या है, पॉजिटिव है कि नेगेटिव ये नहीं पता, लेकिन जो भी है वो कभी बदला नहीं जा सकता। क्यों? क्योंकि हम ना तो नेट चार्ज बना सकते हैं ना तो डिस्ट्रॉय कर सकते हैं। दिस इज कंजर्वेशन ऑफ चार्ज। नेट चार्ज ऑफ यूनिवर्स इज कंजर्व्ड। आप ऐसे भी लिख सकते हैं, वी कैन नॉट क्रिएट चार्ज एंड वी कैन नॉट डिस्ट्रॉय नेट चार्ज। एक बार बोर्ड पे देखें गामा रे। गामा रे बहुत हाईली एनर्जेटिक रे है जिसके पास कोई नेट चार्ज नहीं होता। अगर हम गामा रे को बहुत हाई इलेक्ट्रिक और मैग्नेटिक फील्ड से पास करें तो हमें मिलता है इलेक्ट्रॉन और पॉजिट्रॉन। पॉजिट्रॉन इलेक्ट्रॉन का एंटी पार्टिकल होता है जिसके पास उतना ही चार्ज होता है जितना इलेक्ट्रॉन के पास, लेकिन पॉजिट्रॉन के पास पॉजिटिव चार्ज होता है और इलेक्ट्रॉन के पास नेगेटिव। अगर आप टोटल देखें तो नेट चार्ज राइट हैंड साइड भी 0 और लेफ्ट हैंड साइड भी 0। इस तरह से हम प्रूव कर सकते हैं कि चार्ज कंजर्व्ड होता है। कंजर्वेशन ऑफ चार्ज से मैं ये भी कह सकता हूं कि इस क्लासरूम का चार्ज नहीं बदला जा सकता। अगर इस क्लासरूम का चार्ज नहीं बदला जा सकता तो इस सिटी का भी नहीं बदला जा सकता, इस स्टेट का नहीं बदला जा सकता, इस कंट्री का और अर्थ का भी नहीं बदला जा सकता। अर्थ सोलर सिस्टम का पार्ट है। अगर अर्थ का नेट चार्ज आप नहीं बदल सकते तो पूरे सोलर सिस्टम का नेट चार्ज नहीं बदल सकते। इसका मतलब पूरे यूनिवर्स का नेट चार्ज आप नहीं बदल सकते। याद रखें पूरे यूनिवर्स का नेट चार्ज कांस्टेंट है। लेट्स डिस्कस नेक्स्ट प्रॉपर्टी ऑफ चार्ज, additive nature of charge. When Franklin discovered charge, he assumed there are two type of charge. Instead of giving name them type A charge and type B charge, he given them positive charge and negative charge, so that he can explain when we add electron and proton, one electron and one proton, we get net charge 0. Or he assumed positive and negative charge so that we can understand when we add plus 2 coulomb with minus 2 coulomb, we get net charge 0. So in very short, we can understand additive property of charge means in the calculation of net charge, we need to follow simple algebra like this: positive, negative, plus 1, minus 1, 0. And the next property of charge is non-relativistic. It means, unlike mass, charge on any particle will not change with velocity. Suppose if we increase or decrease velocity of an electron, the charge in one electron will remain unchanged. But if we increase velocity of a particle, its mass increases. With the help of this formula, we can understand if I increase velocity of a point mass, its mass will also increase. But unlike mass, there is no effect of changing velocity on charge. Remember, charge on any particle will remain same if we change velocity. चार्ज की दो और प्रॉपर्टी हैं, बहुत जरूरी है. तीसरी प्रॉपर्टी है एडिटिव नेचर ऑफ चार्ज. फ्रैंकलिन ने जब चार्ज को डिस्कवर किया तो वो चाहता तो दो तरह के चार्ज थे, एक को चार्ज ए मानता, एक को चार्ज बी मानता. लेकिन फिर ये कितना डिफिकल्ट हो जाता कि चार्ज ए और चार्ज बी को जब जोड़ा तो तुम्हें जीरो चार्ज मिला. समझना मुश्किल है. वहीं फ्रैंकलिन ने माना कि चार्ज एक प्लस होता है और नेगेटिव होता है. अब आप प्लस 1 प्लस 2 कूलम को माइनस 2 कूलम से जोड़ोगे, नेट चार्ज जीरो आएगा. बहुत आसान है समझना. ये भी समझना बहुत आसान है कि जब आप एक इलेक्ट्रॉन के चार्ज को एक प्रोटॉन के चार्ज से जोड़ोगे तो आपको जीरो चार्ज मिलता है. क्यों? क्योंकि इलेक्ट्रॉन में, मैंने आपको ऑलरेडी बताया था, इलेक्ट्रॉन में नेगेटिव चार्ज होता है और प्रोटॉन में भी उतना ही चार्ज होता है, लेकिन पॉजिटिव चार्ज होता है. तो जब आप एक इलेक्ट्रॉन और एक प्रोटॉन के चार्ज को जोड़ोगे तो आपको जीरो चार्ज मिलेगा. कहने का मतलब है कि जब भी आप चार्ज से रिलेटेड कैलकुलेशन करेंगे तो सिंपल अलजेब्रा फॉलो करना है. प्लस 1 माइनस 1 0, ऑलवेज रिमेंबर. अब समझते हैं अगली प्रॉपर्टी. चार्ज मास की तरह बिल्कुल नहीं है. अगर हम किसी पार्टिकल की स्पीड बढ़ाते हैं, वेलोसिटी बढ़ाते हैं, तो उसका मास भी बढ़ जाता है. आइंस्टीन ने ये रिलेशनशिप दिया था, थोड़ा इसके बारे में आपको पढ़ना पड़ेगा. अगर हम किसी भी पार्टिकल की स्पीड बढ़ाते हैं उसका मास बढ़ जाता है, लेकिन चार्ज को कोई फर्क नहीं पड़ता. स्पीड बढ़ाओ घटाओ, चार्ज जितना है उतना ही रहेगा. Let's solve some questions based on properties of charge. So the first question is, which of the following charge is not possible? I told you the smallest free to move charge is electron, and in one electron have charge equal to minus 1.6 into 10 power minus 19 coulomb. So charge greater than this is okay, but charge smaller than this is not possible. This is equal to 10 E because one electron has 1.6 into 10 power minus 19 coulomb. If we multiply this by 10, you will get this. So this is possible. Okay. This is also possible. Charge in one electron. This is also possible. Okay. This is not possible because the power is minus 20. And I already told you the smallest free to move charge is 1.6 into 10 power minus 19. Now 1.6 into 10 power minus 20 represent E by 10. I told you we cannot break electron. So how will you get E by 10? So this is not possible. Now let's read second question. Again same type of question. इनमें से कौन सा चार्ज पॉसिबल नहीं है? Out of given charge, which charge is not possible? I already told you this first property of charge, quantization of charge. According to that property, Q is equal to NE, where N must be integer. Means N should be 1, 2, 3, right? Because we can have 1 electron, 2 electron, 3 electron, but we cannot get E by 2. So 10E possible? Yes. E is possible? Yes. 7E is possible. But this is impossible. So answer is this. You cannot get 5E by 2. You will get 2 electron, but from where you will get E by 2? Always remember Q is equal to NE, where Q is charge, E is charge in one electron, and N is number of electrons. Now let's read third question. Charge of the universe is increasing with time, or is decreasing with time, or is constant? Hopefully you remember conservation of charge. we cannot create net charge, and we cannot create net charge, and we cannot destroy net charge. So the charge of universe is constant, right? Now let's go to the next question. On increasing speed, specific charge of a proton. Now what is the meaning of a specific charge? A specific charge means charge upon mass. I told you, on increasing velocity, charge will not change, but mass will increase. So a specific charge will decrease. Remember. So student, I would like to say goodbye to you. Today we have covered what is charge and properties of charge, and questions based on definition of charge and properties of charge. In the next class, I will teach you how to give charge to a body, or methods of charging like induction, conduction and friction. After that, I will teach you gold leaf electroscope. Stay tuned.